Chapter 3. Galaxies are moving. Why are you running away? Edwin Hubble had answered one of humanity's greatest questions. The Milky Way was not the entire universe. Beyond it lay countless other galaxies, scattered across the darkness like islands in a vast cosmic ocean. For the first time, humanity knew it had neighbors. Naturally, another question followed. What were those galaxies doing? Were they drifting quietly through space? Or was the universe far stranger than anyone had imagined? It seemed like an impossible question. The galaxies were millions of light years away. Even if they were traveling at extraordinary speeds, no astronomer could ever hope to watch them move. The distances were simply too vast. Perhaps the problem wasn't our telescopes. Perhaps we were asking the wrong question. Until now, astronomy had been a science of seeing. Each generation had built better eyes. Each generation had looked farther into the darkness. But now, looking farther wasn't enough. The galaxies had already been found. The next breakthrough would come from asking something entirely different. Not, what can we see? But, what is the light trying to tell us? Scientists already knew that white light wasn't really white. Pass it through a prism, and it spreads into a rainbow. Red, orange, yellow, green, blue, violet. Beautiful, but hiding a secret. Stretch that rainbow farther, and hundreds of tiny dark lines begin to appear. At first glance, they look like scratches. They aren't. They are spectra. Every chemical element leaves behind its own unique pattern. Hydrogen has one, sodium another, calcium another, like a fingerprint, or perhaps even better, like a barcode. Each pattern is unique. Read the pattern, and you know what produced the light. A spectroscope is an instrument built to do exactly that. It stretches the light with extraordinary precision, until those hidden patterns become easy to compare. Suddenly, astronomers could do something that had once seemed impossible. Without ever traveling to a distant star, they could discover what it was made of. They could measure its temperature. They could identify the elements inside it. They could learn about places so distant, no human being would ever visit them. The telescope gathered the light. The spectroscope read the message. The telescope taught us to see. The spectroscope taught us to read. Then someone asked an even bolder question. If light could reveal what a star was made of, could it also reveal whether an entire galaxy was moving? My name is Vesto Slifer. When I began trying to answer that question, it was 1912. The world was a very different place. Horse-drawn carriages still shared the streets with the first motor cars. The aeroplane was little more than a decade old. There were no computers, no electronic detectors, no digital cameras. Every observation was captured on a fragile glass photographic plate. Every measurement was made by eye, every calculation performed by hand. And yet, I hoped to measure the motion of galaxies, millions of light years away. Many astronomers believed it couldn't be done. Some nights, so did I. The galaxies were unimaginably faint. A telescope gathered every precious photon that reached the Earth. Then my spectroscope spread that tiny trickle of light across hundreds of colors. The very instrument that allowed me to read the universe also made the universe harder to hear. Questions like this are rarely answered in a single night. They're answered one night at a time. Night after night, the telescope followed a single faint galaxy across the sky while the Earth slowly turned beneath it. There was nothing to watch, no monitor, no photograph slowly appearing, only silence, darkness, and patience. At dawn, I removed the photographic plate and waited for the chemicals to reveal whether the night's work had been worthwhile. Sometimes there was almost nothing there. The image was too faint, too blurred. An entire night's work had disappeared with the sunrise. So I returned the following night. Then the night after that. I adjusted the guiding. I lengthened the exposure, I refined the instrument. Then I tried again. Little by little, the spectra became clearer. The universe wasn't hiding its secrets. It was simply speaking very, very quietly. One morning, everything changed. The spectrum was finally clear enough to study. The familiar dark lines were all there, exactly as I expected. Hydrogen, calcium, sodium. Their fingerprints were unmistakable, except they weren't where they should have been. I stared at the photographic plate. Surely, I had made a mistake. Perhaps I had identified the wrong lines. Perhaps the telescope had drifted during the long exposure. Perhaps the spectroscope itself was at fault. I checked the instrument, then I checked my measurements, then I checked them again. Nothing was wrong. The instrument hadn't moved. The lines had. Not one of them. All of them. Every fingerprint had shifted by exactly the same amount. It was as though someone had gently slid the entire rainbow to one side. I had never seen anything like it. Then I remembered something familiar. Imagine an ambulance racing towards you. Its siren sounds higher than normal. As it passes and begins to drive away, the pitch falls. The siren itself hasn't changed. Its motion has changed the sound reaching your ears. This is called the Doppler effect. Light behaves in much the same way. If an object is moving away from us, its light is stretched ever so slightly. The wavelengths become a little longer, shifting the light towards the red end of the spectrum. Astronomers call this redshift. The change is far too small for our eyes to notice, but the spectroscope could. The fingerprints hadn't changed. The galaxy had. One observation proves very little. Science is built on evidence, not excitement. So I turned the telescope toward another galaxy, then another and another. Each one demanded another night, another photographic plate, another careful measurement. Slowly, a remarkable pattern began to emerge. Again, the lines had shifted. Again, the galaxy was moving away. Then another and another. It wasn't a mistake. It wasn't a faulty instrument. The universe was telling the same story, over and over and over again. Most of the galaxies I observed were moving away from us. For the first time in history, humanity had measured the motion of another galaxy. Not by watching it drift across the sky, not by travelling across the unimaginable distances between us, but simply by reading the light it had sent us. The impossible had become possible. When I began this investigation, I thought I was answering a single question. Could light reveal the motion of galaxies? Instead, I had uncovered a far greater mystery. Why were they moving? Was there a pattern hidden within those motions, or was the universe simply a chaotic place? My observations could not answer those questions. They only revealed the clues. Someone else would have to continue the investigation. Night after night, another patient observer would collect the faint light from galaxies even farther away than I could reach. His observations would extend mine. Together, our measurements would reveal a pattern that neither of us could yet see. His name was Milton Humason. The galaxies were moving. Humanity now knew that. The next question was, what did it mean?